Hello grade 6. Today we will start in a new unit which is about matter and energy. We will begin explaining chemical compounds and chemical reactions. What are chemical compounds? A chemical compound is a substance which is made up of more than one kind of matter united together. For example, water is made up of oxygen and hydrogen. Carbon dioxide, it is made up of carbon and oxygen. Sugar is made up of carbon, oxygen, and hydrogen. Chemical compounds in our daily life. Many compounds are essential in our daily life, like water, salt, lemon, toothpaste, and soap. How can we classify chemical compounds? Chemical compounds are classified into three classes: neutral compounds, acidic compounds, and basic compounds. How can we distinguish between the three classes? Acid or acidic compound has a sour taste. However, base, which is called basic compound, has a bitter taste. And the neutral compounds has neither bitter nor sour taste. Acid burns the skin if it is strong. Base feels slippery and foamy with water. Neutral has no effect on skin. Some examples on acidic compounds: vinegar, soft drinks, orange juice. Another examples on base compound: Odex, Malox, which is used for stomach burning, shampoo, etc. And example on neutral compounds: water, saliva, salt, and sugar. Is there another way to identify the nature of chemical compounds? Yes. This could be achieved by using a colored indicator. What is a color indicator? It is a substance that changes its color with acid or base, and it could be of two types. The first one is natural color indicator, like red cabbage water, grape juice, radish water, etc. Second type is synthetic indicator, which could be found inside the lab, like the litmus paper, which could be red or blue litmus paper, and phenolphthalein, which is colorless. You have to know that color indicators do not change their color with the neutral compounds. First, we'll begin with natural indicator, and we'll take purple red cabbage water as an example. As we are saying, red cabbage has a purple color. If we take an acidic compound and we'll add few drops of purple red cabbage water, its color will give pink or red. However, adding a red cabbage into a base will give green or yellow color. Synthetic indicators. Synthetic indicators will start with the phenolphthalein, which is colorless. It has no color. You have to know that phenolphthalein remains colorless with acidic compound. It does not change its color. So with basic compound, phenolphthalein becomes pink. Second synthetic indicator is litmus paper. We said it is of two kinds. The red one, this is red litmus paper. If I put it inside a basic compound, the color will become blue. However, with acid, it remains pink or red. The second type, which is blue litmus paper, with acid it becomes red. However, with base it remains blue. Let us have an application. Complete the table below. We have compounds like vinegar, baking soda and water. We have to fill the taste, its color with red cabbage, phenolphthalein and blue litmus paper. First, vinegar. If it gives a pink color with red cabbage, then it is what? It is acidic. So it tastes sour. And acidic with phenolphthalein remain it colorless, and they change the blue litmus paper into red. Second chemical compound is the baking soda. If we are saying that baking soda has a bitter taste, then student, it is a basic compound. Basic compounds, they make red cabbage water green and phenolphthalein pink, and of course blue litmus paper remains blue. Third example is water. Water is tasteless, then it is neither sour nor bitter. Therefore, it is a neutral compound. Neutral compound does not change the color of an indicator. So red cabbage will remain purple, phenolphthalein will remain colorless, and blue litmus paper will remain blue. Then which of these chemical compounds is acid, base or neutral? Vinegar, as we said, it is acid, baking soda is base, and water is a neutral. Okay, according to their tastes and their color with the indicators. Now we'll start talking about chemical reactions. Of course, when we say chemical reactions, then we will do many experiments. First, you have to know the definition of a chemical reaction. A chemical reaction is a process where substances called reactants are transformed into new substances called products. Reactants are the substance used at the beginning of the experiments. However, products are the substances obtained at the end of the experiment. They are not found at the beginning. They are produced after the occurrence of a chemical reaction. For example, if your mother is making cake, she will use eggs, flour, milk, butter to obtain the cake. This is a chemical reaction. Why? Because reactants are changing into product. What are the reactants? The reactants are eggs, flour, milk, butter, etc. All the ingredients used. After putting in the oven, they will give cake. So cake is the product. Can we return eggs, flour, milk and butter? No. So this is a chemical reaction. How to present a chemical reaction in an equation form? How can I represent a chemical reaction? A A chemical reaction could be represented in an equation form by writing the names of the reactants and the products with arrow between them. The arrow means give or produce. Example, if I have reactant and product, I will write reactant 1 plus reactant 2, arrow, product 1 plus product 2. Of course, using their names. Application. Here we have hydrochloric acid, which is the acid found in the stomach. If we add it over iron powder, what happens? We will observe bubbles of hydrogens. You are seeing the air bubbles, and iron will give iron chloride. So this is a chemical reaction. Name the reactants and the products. We said the reactants are the substances found at the beginning. So reactants are hydrochloric acid and iron powder. They disappear to produce new substances which are called the products. So products are iron chloride and hydrogen gas. Write the word equation of the reaction occurring. How can I transform this figure into an equation form? We said that we write the name of the reactants and the name of the products with arrow between them. So the word equation is hydrochloric acid plus iron, arrow, iron chloride plus hydrogen. What are some signs or evidences for the occurrence of a chemical reaction? Dear students, there are 4 signs that reveals the occurrence of a chemical reaction. However, in this year we'll talk about 2, only 2 of them. What are these 2 evidences? First one is the color change. If you are seeing a change in the color, then this is maybe due to a chemical reaction, like in the case of an apple. When apple changes its color, this is due to a chemical reaction. And the release of a gas. If you see air bubbles, when we are adding 2 substances over each other, then this is maybe due to a chemical reaction. Application. Here we have 2 experiments, experiment 1 and experiment 2. In experiment 1, we'll dip iron nail inside blue copper sulfate solution. Copper sulfate is a substance that could be found inside the lab. After a period of time, we will observe a change in color from blue into green, and the iron nail will become brown red. However, in experiment 2, we'll add baking soda into vinegar. We are putting baking soda inside a balloon. When we add baking soda into vinegar, we will see blowing of the balloon. Why the balloon blew? Because of the release of a gas. So, first question, name the reactants in each experiment. In experiment 1, reactants are the ones that are found in the beginning, which are iron nail and copper sulfate. However, in experiment 2, reactants that we used are vinegar and baking soda. Pick out the evidence of the occurrence of a chemical reaction in each experiment. As we said, and as we are observing that in experiment 1 the color changes from blue to green in the solution and from silvery into brown orange in the iron nail. So the evidence in experiment 1 is the color change. However, in experiment 2 we see air bubbles and the balloon blows. So there is a release in the gas. Then the evidence is gas release. Now, how does the mass change during a chemical reaction? Do you think that during a chemical reaction the mass will change? Let's see. During a chemical reaction, mass is conserved. This means that total mass of the reactants is equal to the total mass of the product. So there is no increase and no loss in the mass. This means if we have 80 grams of the reactants, the products forms are also 80 grams. So the mass of the reactants equal to the mass of the products. For example, if we are burning coal whose mass is 100 grams and we don't let the gas to go out, we are collecting the gas, then the mass will remain 100 grams. Why? Because the total mass of the reactants is equal to the total mass of the products. Application. Here we are putting on a balance sodium hydroxide and copper sulfate solution. The mass, the total mass of the reactants, which are sodium hydroxide and copper sulfate, is 67.25 grams. After mixing, after adding sodium hydroxide over copper sulfate, also the mass remains 67.25 grams. What happens when we add sodium hydroxide to copper sulfate? A chemical reaction occurs and the products form are sodium sulfate and copper hydroxide. Pick out the name of the reactants and the products and their total mass. The reactants are the ones that are found at the beginning, which are sodium hydroxide and copper sulfate, and their total mass is equal to 67.25 grams from the balance. However, the products are sodium sulfate and copper hydroxide appearing at the end of the experiment. Their mass is 67.25 grams. We pick out the names of the reactants and the products from the document. Before the arrow are the reactants, after the arrow are the products. Second question, what can you conclude? We conclude that the total mass of the reactants equal to the total mass of the products. 67.25 grams equals 67.25 grams. How can we test for some gases released by a chemical reaction? We said that one of the evidences or signs of a chemical reactions is the gas release. How can I know which gas is being released? Let's see. First, if the gas is hydrogen, how can I know that this gas is hydrogen? Simply, we can approach a glowing wooden splint. If it gives a pop sound, then this gas is hydrogen gas. However, what about oxygen gas? How can I know that oxygen is being released by a chemical reaction? Also, we will approach a glowing wooden splint, but this glowing splint will glow more with oxygen, okay, because oxygen burns the flame more. Finally, test for carbon dioxide gas. How can I know that the gas is carbon dioxide? And we already know this experiment from grade 5. Carbon dioxide turns clear lime water into milky color, okay, or cloudy. Application. Here we have an experiment. We are putting hydrochloric acid and magnesium inside a test tube, and we are connecting the test tube to a container containing soapy water. We'll observe air bubbles. If we approach a candle flame, we will hear a pop sound. Then, can you identify the gas released by this chemical reaction? Yes, of course. The gas released gives a pop sound with candle flame. Therefore, it is hydrogen gas. This is everything about chemical compounds and chemical reaction. Thank you for listening and keep safe.